The following is a presentation of exam wrapper number 3, in which problem number 2 is analyzed and discussed. This is from Physics 2212 in the fall 2014 semester. So with the problem statement in the included diagram, we have that in problem 2 that there were 3 identical batteries, each with an EMF equal to V, and they are connected to 6 identical resistors, each with a resistance R shown in the diagram below. And so in part A of the problem, you did determine the circuit I, or the current I within the circuit. And as you see the answer choices here, we'll be able to find the current through a loop rule. We know that there are 3 batteries in the circuit, and then because of that, we know that the EMF produced by each of these 3 batteries is going to be 3 times EMF. Also, the problem states that there are 6 identical resistors within the circuit. So because we know that V is equal to IR, we know that 6V is equal to 6IR. In our loop rule, we can set the 3 EMF from the batteries equal to the 6IR from the 6 resistors. And then by isolating I in order to solve for the current, we find that I is equal to V over 2R. Answer choice D. Part B of question 2 wanted us to determine the potential difference from points 1 to from node 1 to node 3 within the circuit, given the following answer choices. So from the previous problem, we know that I is equal to V over 2R. We've rearranged this so we find that IR is equal to V over 2, and this allows us to find the potential difference between points 1 and points 3. And then since we're looking for the sum of the 2 voltages, the potential difference will be expressed by adding 2IR, or V over 2 plus V over 2, which yields a potential difference of V, which gives us answer choice A. Part C of question number 2 wanted you to find the potential difference this time between nodes 5 through 8. Given the same answer choices, we apply our node rule again, and because we know that they are identical and that they're each an equidistant distance away from each of the batteries, we can say that nodes 5 and node 8 are equivalent. And that as you move from the equivalent nodes, there is no true change in potential because it's similar to a round trip around the loop. And we know that for round trips around any circuit, the potential difference is 0 volts. And that leads us to answer choice C. Now in part D, you're asked to draw a graph of how the electric potential varies throughout the circuit, starting at node 1 and traveling counterclockwise all the way around to node 9. And we know that we should expect that through the batteries, the potential will increase, and while it travels through the resistors, potential will decrease. So the following results should yield this: an increase as we move through a battery, and then down, the potential will decrease as we move down through 2 resistors. And the same holds true as we move around the circuit through 3 batteries, then down through 6 resistors, and then back to the beginning of the loop. So that concludes this presentation of exam wrapper 3, and I'd like to thank you for taking your time to watch it.